Okay, here we go. So last one. Last thing in terms of this question, question 2, is simplify 27x to the power 9 2/3 and simplify this bad boy here. Now, what we're going to do with this is, of course, I'm going to expand the bracket. And this is where a lot of individuals might lose marks. They tend to expand this one here. So they will do, let's zoom in a little bit. They will do 2/3 times the 9, but they will forget to do 2/3 times the 27. That is the weirdest image, but whatever. Y'all get what I'm saying. Make sure you expand it out properly. So here you can see, and that's what I've done. I've done 2/3 times the 9 and 2/3 times the 27. I say times, but it's to the power of. I'm oversimplifying my language there. So 27 squared and then the cube root of it, or you can just type this in your calculator, is just 9. That's all that is. 9 times 2/3 is 9 times 2 is 18, divided by 3. 18 divided by 3 is 6. And there you go. That's it. So the only thing that individuals might lose a mark on with that, like I said, is not multiplying out both parts. This last one here, and again, thanks for concentrating for this far into this tutorial. This part right here is the x squared plus 5x over x squared minus 25 situation. All right, now one thing that is the case is you will notice that these two things have something in common, right? They have something in common. I'm looking at the top part, the numerator only, and you will notice that this is x times x, and this is 5x, right? So this is 5x. So this means that this is x plus x plus x plus x plus x, and so on until there's exactly 5 of them. This is x times x, so it's a different concept. But notice, they both have one x in common. So I'm going to take that out. I'm going to factorize that out. So this is what I've done here. And that is called factorization, of course. I've taken out an x. And just as a step, this is an extra step that actually might add a little bit of confusion. So I will see whether it's worth it. But I've taken out x, which means I have to write it as x squared over x plus 5x over x. And the reason for that, again, let's try and use this pattern, is because if I multiply this back in, then it will be x squared times x. And if I multiply this one back in, it will be 5x times x. So therefore, I have to write divided by x such that they cancel. Right? Hopefully that makes sense. And one other way that I can look at this is, notice that I've said to you that the top one is xx plus 5x. So I use a bit of color here. So what I've decided to do is I've said, well, I'm going to take this x here and this x here, and I'm going to take it out of the bracket to leave x. And then what will be left would be a lovely, finally would be, therefore, let's see if I can get this coloring right for this last bit, x plus 5. That's pretty much what I've done. That's all I've done. I've taken out the fact that they have an x in common. But the correct algebraic way to illustrate that would be x with x squared over x plus 5x. And the x is being divided here so that I can put it back in without lying to anyone. Okay, so this factorization meant that what's left is x with x plus 5. And one more time, just to repeat this once more, is I can multiply that back in and you get your x squared plus 5x, which is exactly what the question had, x squared plus 5x. So you can tell that that factorization is correct. Okay, one last thing to recognize here is we're going to just take a little bit of a sidetrack. X plus 5 times x minus 5. I just want to look at this concept. If I multiply this out using the same system, so I'm going to do this multiplied by that, and this multiplied by this, then this multiplied by this, and that multiplied by that. I'd have x squared minus 5x plus 5x minus 25. And you can work that out, again, in your spare time at a slower pace if you wish. Now, what does that mean? Well, these are going to cancel. They're minus 5x and plus 5x. And so you get x squared minus 25. And this is an advantageous thing to know because it means that if you ever see x squared minus 25, you'd have x plus 5, x minus 5 is a way of writing it. This is the same for squared numbers. So if this was x squared minus 9, I could have x plus 3, x minus 3. Now I'm going to use this by changing this. I'm going to change this x squared minus 25 here to the x minus 5, x plus 5 there. And what's great about this is it finishes off this problem because it means that this cancels out, x plus 5 there and x plus 5 there cancel. leaving you with the most simplified form of x over x minus 5.